Hi everybody, how are you guys doing today? I hope you're faring better with the boat last night than I was. I wasn't feeling too well. So, my name is Kenneth Reitz, and this is Python for Humans. You can find me on Twitter at Kenneth Reitz, and I work for a company called Heroku, which is an application development platform which allows you to push your code up without having to mess with servers. And it kind of goes really well with the things that I'm passionate about, which I'm going to get into here, which include essentially putting the user ahead of the implementation. So as a developer, you can spend your time working on your code, not messing with servers. They sent me all the way here, so it was about 10,000 miles. I live on the east coast of the US, so I'm very thankful for that. And I've been working on my Australian a little bit. And I was told I'm going to try this, but I'm not sure if I can do it right. It was, how you doing? Is that about right? Not quite? You'll have to give me some training later. So, you may know me from the open source that I write. I do quite a bit of it. I'm very passionate about open source, and it essentially, everything in my life revolves around it. My most popular project is called Requests, which is HTTP for Humans, which we will get to in a bit. I also authored a project called HTTP bin, which is kind of this hosted framework, or it's a hosted, essentially, HTTP mirror that allows you to send requests, and it just gives you a nice JSON response with what you actually requested, and a couple different tricks it can do, so you can test how your API clients are working. I also authored Legit, which is a Git workflow tool that's written in Python. It is pretty useful. Envoy, which is sub-processes. It makes a better API, essentially, for shelling out to commands, which abolishes security and things like that. So I wouldn't recommend using it in production. But you may be familiar with that. There's TabLab, which is essentially tabular dataset library. It allows you to build these tables of data that they're pretty simple. They're just essentially regular Python objects, but then you can just export them to CSV and JSON and Excel, HTML tables very easily, which is pretty nifty for generating reports and things like that. Clint, which is a command line application toolkit. It does things like shell command, coloring, and argument parsing, things like that. There's AutoEnv, which is super awesome. It allows you to, for example, you put a .env file in a directory for a project that you're working on, and it is essentially a shell script that will be executed when you cd into the directory. So then you can automatically activate a virtual env and things like that when you're hopping around projects. It's pretty useful. And then there's probably the most popular one that I've done is called OSX GCC installer. And that essentially allows you to install GCC on your Mac without installing Xcode. And the main purpose of that is to provoke Apple's lawyers. They give me a call every once in a while. The more I do open source, the more I try to push these different concepts of these lessons learned. And I'm trying to push this new philosophy in all the code that I write, and it's essentially open source everything that you could possibly open source. And there's a lot of benefits that come from that. When you start building your tools for open source, even if they're not going to be published or seen by anybody but the company, for example, if you're writing internal code, a lot of really great things can kind of arise from that constraint. You have components can become concise and decoupled. So usually when you work on an open source project, you can't make it extremely specific to your problem. You have to make it nice and general and loosely coupled, so there's not a lot of overlap between different components. And that's great when you're building applications in general, because it can really force you to think about things properly instead of just kind of hacking things to get things done. So, and that's a lot of what I really believe in software development, is trying to do things the right way rather than the really quick way. Of course, there's time and place for everything, but it's what I'm passionate about personally. So when you start to build things for open source, concerns start to separate themselves. A lot of best practices emerge. For example, you have, you wouldn't be storing credentials right in your code base if it was an open source project, which you shouldn't be doing for your projects anyway. Documentation. I'm sure, how many people have robust code bases in your company that have like no documentation at all? Yeah, so you all feel the pain of that, I'm sure. So if you were to treat all of your projects as if they were open source, we wouldn't have that problem. And the code could be released as open source at any time if you built it this way, which is an excellent benefit. Usually when someone goes to open source an internal project, they essentially go rewrite all the history and they make sure there's nothing in it, and they do a fresh release, and it's much better to just do it properly from the beginning. So we are all here because of open source. We love open source. Python is open source. There's a lot of things that, other than that, that draws us to Python in general. We all, I'm sure, share a very dark past. We've all worked with Perl and Java, PHP, Cold Fusion, Classic ASP, Scheme, all these other crazy languages. And there are these things about Python that really attract us, and they're the reason that we come and we spend all of our time and are at this conference. You're either here because you're using Python, or you're here because you're interested in learning more about Python, or the ideals of the language they appeal to you. As Chris alluded to, there is the Zen of Python, which is kind of the core of what our philosophies are. If you were to represent them in a very concise and short way, you would have the Zen of Python, which is PEP 20, which includes 19 statements, the 20th of which has never been written down. I'm not sure what it is. If anyone knows, please tell me. But essentially, it's these line by lines of things that are kind of represent the philosophy of the Python ecosystem. Some good examples of this that we're going to cover today are that beautiful is better than ugly. If you have a code base that you're looking at all day long, you're going to be reading your code 10 times as often as you're going to be writing it. And Python in general goes out of the way to make sure the syntax is as beautiful as possible, and there's not a lot of crud in the way. So beautiful in general is better than ugly. Explicit is better than implicit. We go out of our way to make sure that everything that is happening in a code base or in an application is actually explicitly declared, so that if you are calling a single function, for example, it's not going to actually do all these magical things in the background, typically. And if there's not going to be any environment variables, or there's not going to be any, I guess, just in general, like context locals that weren't necessarily explicitly declared and put there. And a lot of different frameworks can break this if they want, and so it's a little controversial, but in general, we try to be as explicit as possible. If you work with a language like Ruby, they spend a lot of time, everything's just kind of crazy, and you have like all these variables that just exist from nowhere, and it's monkey patches that like affect every module that you have imported. I think that's the biggest difference between us and Ruby, really. And as you can see, it kind of permeates through absolutely everything we do. So this is a really good, as engineers, we like things to be explicit. So I think it's a big win for systems people. We have simple is better than complex, and complex is better than complicated. So essentially what happens is you'll build a code base, and you can start layering it and making all these like advanced handling messages and these, what's the best way to say this? Essentially, it's really easy to write really shitty code. So in general, I try to avoid that. And a lot of systems really pride themselves on complexity over anything else. And Python in general does the best to do the opposite. So I think that's what separates us from Java. If the implementation is hard to explain, it's a bad idea unless you are PyPy, which I think we should amend the PEP to say that. Essentially, if you have a difficult time explaining to someone like verbally or textually online, essentially it's probably not a good idea that you're doing that in the first place if it's difficult for you to explain. Pretty simple. And this is the most important one, and that we are going to cover today. It is that there is one, and preferably only one, obvious way to do it. This is something that really separates us from a lot of other languages. You have things like Perl and Ruby where they have like 75 different modules that do the same thing. In Python, we actually have a problem with that in a lot of ways, but for the most part, we do value the concept of having one obvious way to do it. So you've chosen Python for, let's say, your first project, right? You are going to go and you are going to build an awesome tool, and we have all these values. It's going to be excellent. You're excited. And finally, a culture of engineers that understands the way things should be done. So welcome to paradise. Lies. Not the case at all. So we are going to start out with hitting the GitHub API. For example, let's say we know Ruby, and we are going to try to write this code in Python. So the first thing we're going to do in Ruby, which is it's not the prettiest code, but it's pretty functional, is we import an HTTP module called net HTTP. Has a nice namespace. And we import a URI module. Then we take the URL that we're going to be hitting, and we parse it with the URI module. And then we have the URI object that we set aside. And then we create a new HTTP connection with the parsed host and port from the URI. And we tell that connection to use SSL. And we create a new GET request, pass it in from the URI to the URI, and then we attach basic authentication with the username and password. And we get our content body back with the actual request method. It's pretty simple. It's pretty straightforward. It's a little monotonous, but there's no surprises here. This should be like kind of an obvious thing to do. So we're going to take this script, and we're going to port it to Python. So the first thing you're going to do when you try to do this is you're going to go through and you're going to look at where's Python's net HTTP library, and you're going to find a lot of different answers that are not very obvious. You'll find the HTTP lib module, HTTP lib 2, urllib, urllib2, restkit, many, many others. So several hours later, you're going to be searching, and you're going to find that urllib2 seems to be the best practice according to the community. If you go in Stack Overflow, you'll probably see that in most of the answers, and that's the most modern version. It's in a standard library. So you're going to go through, and it supports like basic authentication and all these things that you need to do. So you're going to try to do this the proper way. The explicit is better than implicit and everything. And this is what we're going to come out with. And it took me probably 2 hours to write this. So essentially what you do is you import the urllib2 module, and then you have your URL that you've set aside. And you're going to create a new request object from that URL. And then you create a HTTP password manager with a default realm as the password manager. And then you take your URL, attach it to the password manager with the URL passed in as well. And then you create an authentication manager that called HTTP basic authentication handler. And then you pass in the password manager into the auth manager. And then you create a urllib2 opener that you build from the auth manager, and then you have your opener. And then you install the opener, and then you can open your request and then get your response as a socket object. What the hell? And I actually lied. This is it's more complicated than this. So essentially, the GitHub API actually will go through, and if you are requesting a protected resource, for example, a private repository, most services, I believe it's a 403 they will return. It says not authorized, and GitHub will do a 404 saying not found. So they don't act like they even know what you're talking about when you ask for a particular repo. So that way I couldn't go on your account and then just try a bunch of repos and see what the names of your projects are. So essentially, so the way that a lot of libraries work is they'll just, if you're explicitly passing in the authentication, the basic authentication for a request, it'll just send it because you are being explicit. And if you go according to spec, and which was what the urllib2 does, it will only send it if it gets the proper header back that says, hey, I need authentication, not, hey, I don't know what this is. So we have to do this thing where we write our own forced basic authentication handler. And we have to do this crazy regex and essentially override the 401 and then send that to the 404. So it's yeah, I mean, if you were gonna if you had to write that in order to do this very simple task, I think that you would essentially leave Python and never come back. The problem is that it's unclear which module you're supposed to be using in the first place. If you search online, the prognosis seems to be urlib2, but the docs, it doesn't even show you how to do essentially any of the things that I just showed on the slides. You'll find, if you search online, you'll find some pretty good resources. VoidSpace has a really great urlib2 guide. But those aren't part of the standard libraries documentation. And the API, even if it was extremely well documented, I don't think anyone in the room probably would enjoy writing this code. This is a very serious problem. A lot of people think that this is probably not a very big deal. You kind of, if you're working on a single project, you just kind of write your little shim that makes your requests for you, and then that's kind of it. You don't have to worry about it. But I think it's one of the biggest problems in the ecosystem right now, and it's essentially HTTP is our universal protocol that we use for almost everything nowadays. If you're getting into like service-oriented architecture or just even building simple web apps that interact with social media, all of these tools are all built around HTTP. And if it's that difficult to make a single request to a developer website like GitHub that has like one of the best APIs around, think of how hard it would be to do on your own infrastructure. It would not be a fun task. So HTTP should essentially, in my opinion, be as simple as a single print statement. So the solution is simple. We need to build elegant tools to perform these tasks. We need what I like to call pragmatic packages. Pragmatic means that you are dealing with things in a sensible and realistic way that is based on practical rather than theoretical considerations. If you go through and look at the urlib2 documentation, you'll see lots and lots and lots of theoretical use cases that these different authentication managers and handlers and openers fit. But at the end of the day, 99% of the time, you're going to be probably doing the same like 10 things. You don't need to do everything possible. So essentially, the urlib2 method is not pragmatic in any way. It is based on theoretical rather than practical considerations. So I like to call Python for humans essentially taking everything that you do in Python and trying to make it as pragmatic as possible. So we'll do that, for example, with this HTTP library. When you break down HTTP, essentially what you'll see is it's a relatively simple protocol. There's a couple nuances, and it can be difficult to work with. But at the end of the day, there are a small set of methods with consistent parameters. You have head requests and get, push, post, put, delete, etc. And all of them accept, that you can have headers attached. They have URL parameters for like queries, and you attach a body with the request, the body or form data. And essentially, that's all HTTP really is at the end of the day. I don't see anything in here about authentication managers and authentication broker systems and openers. So urlib2, when you try to use it, is quite toxic. It's extremely over-engineered for these very simple tasks. It abolishes almost all of PEP20. The docs are impossible to read. HTTP is a fairly simple protocol, and urlib2 is not. And if you were, let's say, learning Python and trying to do this, I really feel like it would scare a lot of people away. So enter requests, which is HTTP for humans, which is the library that I wrote that I'm trying to push to help fix this problem in the Python ecosystem. Essentially what you do to do this exact same thing is you import requests, you have your URL, and you have your username and password, and then you make a GET request with the URL and the authentication, and you get your response. And that's it. Very simple. Achievement unlocked. It's a small set of methods with consistent parameters. It has every single method right there, the head, the get, the push, the post, the patch, and the delete. And they all accept headers, URL parameters, and form data. Do this. Do this with everything that you ever have to go, and if you have to go and find the documentation and reference it every single time you use a module, and I'm sure all of us have many modules like this. Subprocess is another good example of something that you have to essentially reference the documentation every time. If you have to do that, you should either be finding a module that's better and easier to use or building a new module. And not saying that those libraries shouldn't exist. They're often very good low-level modules that need to exist, but having a layered API on top of that that makes it actually usable to a developer is a much better approach. So to do this, there are a couple tips. You can fit the 90% use case, essentially. So you try to fit those pragmatic considerations and not the theoretical ones. 10% of people will come to you and they'll be like, I can't do X, Y, Z. And essentially what you have to say is, I don't care. I want this to be easy to use and actually practical. The API is really all that should matter when you're building these tools, and everything else should be essentially completely secondary. And I mean absolutely everything. You have your features. If you build the API first, all these other things can come later. So you can have features later that fit that other 10% if you want. You don't need to necessarily be extremely efficient in the beginning. You don't have to have extremely great performance. You don't have to fit the corner cases. Everything should come after the API. So you can do this pretty easily. If you start, when you want to write a new package, essentially what you can do is write a README first before you write any code. So you go through the steps, and you will write, essentially, you have this is what this project is, and you can have a few little examples of some different function calls and what they'll return, and how you'll actually use the module, and then you can go through and actually build the module. There's a lot of different terms for this. It can be called README-driven development, or it's pretty awesome. I like to call it, what do I call it? Responsive API design. A couple other things. Essentially what it is it allows you to actually interact with the problem at hand and build something the way it should be built, and then everything else can happen underneath. If there's a lot of complication in making these simple calls that you have in your README, you can do a layered API where you have lower level things that are happening in the background. But at the end of the day, the API is what the developers are going to be interacting with, and that's what really matters. So you can pivot as you go along. So at first, requests really wasn't that great of a library. The API was pretty decent, but it deeply resonated with everybody. And over time, the features grew, and the API really never changed that much. So today, well, originally it was running on urllib2, which is kind of ironic because I actually had to go through and essentially the thing I hated the most in the world I had to intimately become familiar with in order to build it, which I don't know, it wasn't the best. So in the end of the day, I ended up switching and just using the lower level, even lower level APIs directly. And so today it supports cookies and sessions. It has content iteration, so you can essentially iterate over your content as you're downloading it, so you don't have to have it all in memory. It'll automatically decompress zipped responses. You can do file uploads. It has an asynchronous module that has a built-in keep alive and connection pooling support. It has a callback hooks, proxies, OAuth, all kinds of stuff. It's been downloaded over 500,000 times. And I gave this presentation a couple weeks ago, and it was 400,000. So it's I haven't plotted the graph exactly, but it's pretty crazy. And a lot of really major companies use it, and I'm very thankful for that. But why am I telling you this? Cool story, bro. Essentially, we all need better APIs, and we want them. And the success of this library kind of shows that it's worth your time as a developer if you're building tools like this, and it's worth everybody else's time because it saves lots and lots of developer frustration, and it helps the Python ecosystem because those people that might have turned away before won't anymore, and that's really important. So when you go through and you start building things like this, you'll notice that there's a lot of other barriers to entry in the ecosystem. I try to cater as much as possible to people that are coming new to Python. Or, for example, if they work in a different field in Python, they start doing HTTP, for example, they can, you need to make it as simple as possible. So, because Python is a very broad language, it's used for everything under the sun. So making things in your quadrant as easy to get into as possible really has a lot of benefits. So some other problems in Python that really make it difficult for newcomers are file and system operations. There's quite a few modules. I'm sure all of us have the same problem where whenever we need to do something, we have to figure out if it's the sys, the shutils, OS path, or IO module. You kind of get lost in all those. It's really difficult to run external commands with a subprocess module. Once you figure out how to do it, it's not so bad, but it's not. It's more of a documentation problem. And I really feel like this blocks DevOps people from adopting Python. In Ruby, it's really easy to shell out commands to your base system. And in Python, it's not something you really see people doing very often. So I think that's probably a big reason that all these system administration tools are built with Ruby. You have like Chef and Puppet, and they're not built in Python. So who here, let's say, has installed Python on their Mac? All right. So how many of you, keep your hands up. Well, actually put them down, never mind. How many of you installed it from python.org? You just double-clicked and ran the installer. OK. How many of you installed from Homebrew? How many of you use the built-in system Python? Very bad, don't do that. How many of you use MacPorts or Fink? For shame. Who built it from source themselves? Excellent. I mean, what happened to there being only one obvious way to do it? I mean, essentially, we have this beautiful operating system that everyone is attracted to, and it's, considered by many to be one of the better platforms to develop on, and yet we have all these people that do all these different things, and it's not very obvious which thing you're supposed to do. So there's some other questions when you're building a Python is, should you use the system Python? You have to pick if it's 2 or 3, which will get more complicated in the future. You have, Python.org, you have to pick 32-bit or 64-bit. Should you build from source? And if you're using, if you're on a Mac, you have to pick if it's a Unix or a framework build, and most people have no idea what that is or the implications of that. And again, there should be one obvious way to do it. Some other problems is there's XML Hell. Essentially, etree really annoys people. And LXML is a really awesome library. The documentation's not so great, but once you figure it out, it's really, really powerful and efficient. But it can be really difficult to install for a lot of people. And that prevents a lot of people from building tools that they would otherwise be building. For packaging and dependencies, to a newcomer, it's not very obvious. For example, if you're on a Mac, easy install and you're using the system Python is already there, and people think that it's built into Python, and it's not at all. So you have to decide between pip and easy install. People will realize there's no easy uninstall, which is pretty easy to get them to switch to pip then, but it's a pretty big barrier to entry. Distribute versus setup tools. I mean, should be using distribute, I guess, but no one really knows why, and it's kind of not obvious if it's even being maintained more than setup tools now. Setup tools does appear to be built into Python on OS X, and people ship a lot of broken setup.py files, for example. You'll try to compile a library that has a lot of C extensions, and it just won't work, essentially. And another big problem is that people will release packages onto the cheese shop, and they won't be on the cheese shop. Essentially, they'll be on GitHub, and they'll be like, go check out my library, and it's definitely not the way you should be doing things. Some other complications are you have to decide what module to use when you're doing date times. There's the datetime module, date, time, calendar, date util. When you try to install date util, it won't work if you're on 2.7, because it'll install the Python 3 version by default, and you have to go specify a specific release. It's a nightmare. There's time zone hell, and we're not going to get into that, but I'm sure you all feel the pain. And the standard lab can generate but not parse ISO 8601 dates. Just little things that really kind of frustrate newcomers. Unicode. We're not really going to get into this, but Unicode. Essentially, you can go through and I think eventually what happens is you'll Google this one, or you'll find on Hacker News or something, this one blog post or this presentation that will really kind of make it obvious what you should be doing. But it usually takes a year or two for you to get to that point, and it's it's not a very easy thing to get into and to understand properly. Python 3 makes it a lot better, but anyway, Testing, there's a little bit of confusion around what kind of test runners you should be using. There's the built-in one for unit test, I believe, has a test runner. There's nose, there's py.test, there's a test, there's all kinds of stuff. And there's doc test, and people sometimes will use that for pretty robust, serious testing, and they shouldn't be. Little things like that. Installing dependencies. Okay, so if you remember the name of the MySQL module when you're trying to install it, I mean, who here has ever forgotten the name of that module? Yeah, it happens constantly. Once you remember the name, you have to try to install it, and it's that's all that needs to be said. It's quite frustrating. That's just an excuse to be using PsychoPG and Postgres, but that prevents a lot of people from moving to Python. You have the Python imaging library, which is really robust and pretty nice, but it's hard to install. It's really simple once you figure out how to install it, but getting to that point, it's not in the documentation. It can be very frustrating to people. LXML again. ModWizG can be difficult, sorry Graham, to install against, essentially if you're trying to build it and things like that, or make very specific Python changes, and you're on Ubuntu, for example, you'll just use the Python that comes with ModWizG, and makes it a little difficult to to decouple those things. So my solution to a lot of these problems is to build a tool or website, a resource called The Hitchhiker's Guide to Python, which is available at pythonguide.org. And it is the core message is that you shouldn't panic and you should always carry a towel, of course. But essentially what it does is it documents all of our best practices, and it is a guidebook for newcomers, so they can go through and they can see exactly what best practices we have and what they should be doing. The python.org site is really great, and there's some real good efforts right now to try to kind of change its purpose. But at the moment, it's essentially, it's not going to be opinionated in any way. It's not going to say use Django and Flask. It's not going to say use this version of Python on OS X and install it this way. Essentially, there needs to be another resource for these things, and that's what Python Guide tries to fill. So it's a guidebook for newcomers, and then it's a reference for seasoned veterans who, for example, are moving to a different area in Python they don't have expertise in. And of course, don't panic and always carry a towel. Some best practices it recommends, for example, is that you should be using distribute and pip and virtualenv. That's right in the installation guide for Python, so you do that right from the get-go. There's explicit installation directions for every operating system, and this is all open source and on GitHub. So if someone believes that the way I'm recommending isn't correct, they can open up an issue, and we can be discussed as a community, and we can decide what is the obvious way to do it. It instills a resistance to doc test, and it teaches the adamant use of datetime.utc now with time zone naive date times. Yes. But there's only one rule on the website, and it is that there should be one, and preferably only one, obvious way to do it. Once you go through and build this, it makes Python a lot more accessible. It lowers the barrier to entry. It sets developers on the right path from the start, so you don't have these people building these terrible frameworks that are just the worst, or these tools that are they're completely isolated from the rest of the Python ecosystem because they do their own things. And essentially, it allows us to practice what we preach. So I recommend, if you guys want to check that out, it's at pythonguide.org. It's also on GitHub. And first when it was launched, essentially it was an outline, and about 120, I think, people have sent pull requests, filling in their own section that they're experts in. And it's really grown quite a bit. And I think it gets about 2,000 visitors a day now. And I haven't really done a ton to push it, so it's going to be, I think it'll be pretty great once we get a lot more people involved and have pull requests happening every day. It'll be pretty awesome. So A, you can use it if you're new to Python and you want to learn more, and B, if you want to contribute, which most people in this room, I believe, can. Even if you're a newcomer, you get to see the things that confuse you, and those are the things that should be in the guide. So I definitely recommend you check it out if you'd like to help. So the manifesto of my presentation is simple. Simplify your terrible APIs and document our best practices. That's it.
If there are any questions, could you please come and form a queue up around here? Conveniently, our first question is where I'm going to start the queue.
Hi there, great talk, thanks. I was just looking at the source of requests, and deep in the packages library, there's URL lib3.
Correct.
What's happening there?
So URL lib3 is a kind of an ironic name. Essentially what it is the developer whose name is Andrei Petrov. He went through and he saw that URL lib and URL lib2 really have nothing to do with one another. So he wanted to build a new HTTP library, and he decided to call it URL lib3. So essentially what it does is it is HTTP lib, it's slightly wrapped, and it adds connection pooling and file uploads, essentially, and keep alive. So that's what URL lib3 is. And I work very closely with the developer of that. And essentially, I take the whole source tree and embed it into requests instead of doing a dependency, because I kind of consider it a fork. Like if I'm waiting for him to make a change, I can make the change in the meantime. And requests I want it to be fully embeddable in your application. If you're building a lot of system tools, essentially, like an API client that's on the command line, it's really valuable to put those things into the source tree so that it doesn't conflict with other things. Like the HTTP lib2 had a big thing for a while, like the Epio client and the Gondor client were different than like what the GitHub 2 API required, and like you could never install those all in the same environment. So embedding those things in system tools, I think, is pretty valuable. So that's why I embed it.
Second question this time. You're a bit slow off the mark.
I am. Couldn't stand up fast enough. Okay, the question I've got is essentially one about community management and how this sort of philosophy you're talking about, which I'm completely on board with, fits into the greater Python ecosystem. One of the big selling points of Python has always been batteries included. You don't need to worry about anything anywhere else because you just download it and it's there, and all the things you need are there. And there's a sort of a trade-off between, one, having the 90% solution, which works for most people, and having the solution that works for everybody, batteries included. I wasn't around for the development of HTTP lib2 or URL lib2 or any of those, but I can see exactly how that conversation got us to the point where we have openers and auth managers and all the rest of it, because you do want to have all these things you can do in HTTP that requests can't do. Most people aren't going to care about them. I just interested in having your comments on, when does requests get into the Python standard library? Should it be in the Python standard library? Why is it not? Why should it not be in the Python standard library? And that issue of how does the community deal with having more than one way to do it externally, but still recommending one that is the right way to do it, but isn't in the standard library? And so those sort of issues of
So essentially what happens is when you're trying to fix I think problems in Python in general, there's two different approaches you can take. You can take the approach of going through the PEP process and like going top down essentially, or you can just kind of build something and then if the official community wants to respond, it can adopt it. And that's the path that I try to take. So I'm not going to go and like start a PEP to like fix HTTP before I start working on a great library. I'm going to build it and just and I'm not going to do the same thing with Python.org. I'm not going to to me, I'm not going to waste my time going through the I'm trying to think of the right word, but essentially the bureaucracy of going changing the Python.org site. So for me, building my own, that's proper. And then if Python.org wants to adopt some similar things and it can happen, that can happen. So. As far as the standard library is concerned, I would love requests to be in a standard library, but it's definitely not at that point yet. It's a very stable library, but I'm developed quite iteratively on it. So essentially the standard library, as they say, is where a library goes to die. In a good way, though. So essentially,
It's a burial with honors.
Yes, exactly. Yes, you can't really change it once it's in there, and it's not. I wouldn't have control over it anymore, which is fine once I get to that big I'm done state, essentially, and it's only bug fixes. But I'm not at that point yet. So, yeah, and essentially, batteries included is a really great system, and but it doesn't necessarily. You have to be really careful with what you're adding to the standard library, essentially, and things can change pretty quickly. So I think there's a big value in encouraging people to be using packaging and not just relying on the standard library. I feel like that's the best practice nowadays. So yeah, it'll be in there one day.
Okay, we have time for one more question.
I was just curious about your comments about doc test.
Yes.
I was wondering what it was about doc test that you think it's not a good solution, and what you see best practice as in testing.
So doc test is really nice, and it's a very elegant solution for essentially testing your like README driven development in a way. So at the top of your module, you'll say like, this is how I use it. Or in your Sphinx documentation, you can say, you know, these are the steps, this is what the output should be. And you can test that, and that's really nice. And if you're building, I think, like a one-off script, or it's a small thing, or you want to sanity check your code examples, I think it's a great tool for that. But you know, some people will go down the line and they'll actually build like their entire test suite for a very robust application all in doc test, and that's there's a lot of problems with that, you know, because it's not actual code, you know, it's like a string that they're manipulating. So unit test is a really great module, and you know, that's essentially what you should be writing your unit tests, and I think the integration tests as well with unit test, and then running them with something like Nose or PyTest, or running them directly works really well. PyTest in general is really great, but like it has a specific time and place, and I think it's overused a bit, is essentially what yeah, absolutely.
Right. As a token of our thanks, let's wait for Josh to actually bring those over. We have this fantastic PyCon Australia Hobart 2012 coffee cup.
Excellent. Thank you.
A bag of African swallow coffee beans from Ritual Coffee Tasmania to put inside the coffee cup.
Is it African or European?
No, definitely African. And a 500ml bottle of cask strength single malt Tasmanian whiskey with thanks to the Lark Distillery.
Excellent.
Everyone please thank Kenneth for a fantastic keynote.